normal distribution is actually standard. What do you think a standard means? Anybody? You think a standard means? By the way, distribution is what? It's another name for random variable. So this is a random variable, and every random variable has, remember, a mean. So a standard means the mean is 0, and the standard deviation is 1. That's what it means to be a standard. Okay? Also, since this is a random variable, the whole thing has to add to how much? 1. To 1. And you can see this is symmetric, so from here to here, this is 0.5. And from here to here, this also has to be 0.5. Also, notice that this is technically the y-axis, and this is the x-axis. So x can be positive or can be negative, but y always has to be what? Positive, because the area represents the probability. Okay? All right, so first you need to learn how to read the table, so let me tell you what I mean. Let's say that this area, so I put this here, and I tell you the area in yellow, which is this. Okay? So where is the color yellow there? So let's say I tell you the area from here to here is 0.9. Okay? So it does the area in yellow, okay? Which is technically what the table is going to give you, okay? So if that's the case, then how much is the area in green? 0.1. How do we know that? Okay, so pay attention to this very carefully, because if you don't understand this, nothing's going to make sense. So this is very, very basic. So if this is 0.9, that one has to be 0.1. Is that clear? Okay, now, what about this part in blue? So let's look to this part in blue. How much would be the blue area? 0.4. Right? Any complaints on that? Okay, now, apparently people have issues with more than one decimal. So what about if this was 0.9344? How much would be the area in blue now? What would be the area in blue? That will not change anything. You just have to add the decimals, right? This should be, well, 0.4344. Is that okay or not? So that's very important you understand that concept. So let's say that we have the number here 1.45. So if you look to the table, the value that corresponds to the 90 what? 9265, which is this one right here, right? You see that? All right. So then that's the area that's going to be what? The yellow area, or the area to the left. Use the same coloring. What was the value on the table? What is it? 0.9 what? 265. So that's the yellow area. Okay. So if I ask you for that, that's the answer. You're done. Like the question, if the question is this, what's the probability that z is less than 1.45? Then the answer will be what? 0.9265. Is that okay? Say that instead, the question was this: what's the probability that z is greater than 1.45? Again, if you look to the table, still gonna give you 9265. But this time you want the green area, right? Mm-hmm. And so how do you find out the green area? It will be 1 minus 0.9265, which is how much? 0 what?
0.0735.
735. I think I have an extra zero here. So it should be like that. This is the decimal point, sorry. So, yes. All right, so, is that okay? And the last thing, it will be this. What about if the question was, what's the area between 0 and 1.45, which now it will be what, this blue, the blue area, right? Remember, this is 0, so what will this be? It will be 0.925 minus 50%, or minus 50. So this will be what, 0.4265. Right? Any questions on that?
Yeah.
Yes.
To that last one again?
Can you do that one more time?
Yes. So again, remember that from here
From there.
to here, the table is going to give you 92.65. The table doesn't care what the question you have. The table, if you look to 1.45, the table says the area, the yellow area is 92.65. The question, this one, says you only want the area between 0 and 1.45, which is the blue part.
Right.
The blue part is this minus 50%. So that's how you get 42. Or not, remember how it was 0.4? Why did we get 0.4? Because it was 0.9 minus 0.5. Okay? Is that clear? Yes?
I want to do it. Would I not do 0.5 minus the green? Because then I would know. Because I know that that's 0.5 in total, and now just subtract green, so 0.5.
You can do 0.5. Yes, you can do that too. The problem is that the table is going to give you the yellow part, not the blue part. So that's why you cannot do the 0.5 minus that one. So because once you look at the table, you look for 1.45, it's going to tell you the area is 92.65. Doesn't matter what question you have. Yes? So this is saying what? Find the probability that C is greater than what? 2.21. So 2.21, remember this is 0. 2.21 is here. Greater means what? The area to the right, which in our case is the green area. And this question, this is what you want. Okay? The table is going to give you what? Okay, so again, you look to the table. Let's do this one more time. You look to 2.21. What's the area there? 964, right? Right? Anybody has any issue, you have to find the value. No? All right, so then the table says the area from here to here, which is what? The area we call the yellow area. Remember, the table always gives you the yellow area. That's point what? 8864. Okay, now the part that you want is the green area. So how do you get the green area? 1 minus that. So this will be 1 minus 0.9864, which is how much? 0.136. And that's it. Right? Any questions on that? All right, you need to. So first, you need to shade the part that is asking you. And remember, 0 is here. 1.75 somewhere here. You don't have to measure and be precise, okay? Where it is 1.75. And less means what? The area to the left, which in this case is what? The yellow area, right? If you look to the table, remember the table will give you the what? The yellow area, which in this case the table gives you how much? Is 0.9 what? 99. All right, now this time the table is always going to give you, remember, the yellow area. That's exactly what you want. Do you need to modify anything to this? No. So that's the answer. So the answer is what? 0.9599. And that's it. All right? Any questions? No? I told you this was easier than driving on the 405. So. All right. Any complaints on this? No? Okay, now the next question, part C, is probably the hardest one. So you can do this. Life is good. If not, well, it's not good. All right, so try that one. So the first thing is, what is the area you're trying to find? It's between minus 1.3 and 2.21. 0 is there. Okay? For now, just pretend the negative 1.3 is not there. So if the negative 1.3 was not there, you look to the table for 2.21, right? We did this already. For 2.21, what's all the area that goes to the left for 2.21, which is the one that we call the yellow area? What is it? It was 0.9864, right? So we're gonna use that to find out. Remember this one? That's what we call the blue area. So how much is the blue area? 40 what? 4864. But okay? So technically you're gonna do the same thing now with the 1.3 pointing to the other direction because it's negative. Okay? So you have that blue area that we found. If you go the opposite direction, and this is what I mean by opposite direction from here to here now. Now this will be the yellow area, this will be the green, and this will be the blue area. So you want to figure out again what is the blue area, or blue area right here. So first you need to look to the table and figure out what's the value. So what's the value for 1.3? Is 9032, right? 0.9032. So therefore, how much would be the blue area? Using the same logic we did for the other one. We 4032, right? All right, now take a wild guess. What do you think we have to do? What do you have to do? Add. Okay, so then you add this is 0.4032 plus what? 0.48. Doesn't want to write here. 64. And how much is that?
Wait, plus what? But you didn't.
It should be 4864. It doesn't want to write it for some reason. So this is point what? I think that there's a dead pixel there now. So this is what? If you add the two, what is it? 8896. Well, as long as it works, don't be too picky. Okay, so, all right, is that okay? For the calculator to work, okay, so let's do now the calculator. For the calculator, this only works, remember, for TI-83 or higher. You don't have one of those, you are out of luck, okay? But the table works every single time, so it doesn't matter. Okay, so this is what you're going to do. The calculator only works with, you need to have a lower bound and a upper bound, okay? And that's why it's required that you shade the area that you want. So the calculator, you need to have the lower bound and the upper bound, which could be negative, positive, and so forth, okay? So this is how you do this. Go second, the same we used before for the binomial. Then variables. And then there is a key that says number 2. And make sure you pick the one that says normal CDF. Never pick the PDF. It has to be CDF. And then you're going to enter the lower bound. So let's do this problem right here. If you look to this one, the one we did right now, what's the lower bound? Negative 1.3. What's the upper bound? 2.21. Now, when you enter this, though, the negative sign, make sure you use the one in parentheses that says negative. If you pick the minus sign, it will give you an error. So this is negative 1.3, comma, what's the upper bound? 2.21. And this should give you exactly the same answer, which was 0.88, what? 96. Okay? Yes. If you have negative infinity or positive infinity, for infinity, positive infinity, just use 1000. And for negative infinity, minus 1000. Just make sure you use the minus sign in parentheses, otherwise it's going to give you an error. Okay, so how do we know that this is the area to the right? Because it's what? Greater, right? So this means area to the right. Right? It's telling you the area to the right is this. Okay? So, for lack of a better name, we just call this A, but this is technically the letter Z also. Okay? So, this is telling you that this area is 1.025, which is what we used to call the green area, right? Remember, the table is only going to work with the yellow area. What is the yellow area then? Point what? 90, 9 what? 975, right? Okay? 1 minus 0.025. Okay? So then, this is the one you have to look for in the table. And this is what I mean by look for. So you're going to go to the table and look for the closest thing to 0.975. Sometimes the value is not there, so you have to find whatever is the closest. In this case, it is. How much is, what is right?
0.96.
Yes, which is right here, right? You see that? That corresponds to 1.9, right? And 6 from the top. So therefore, that means this came from 1.96. And that's the solution. That's it. That's how easy this is. Okay, well then. All right, so then this is equals to 1.96. All right, any questions on this? So this is for part B, this is telling you already what? That A is here, right? And it's literally giving you the yellow area, right? It's telling you this is 0.9. So therefore, you have to look for 0.9. Now, 0.9 is not precisely on the table, so you have to find whatever is the closest thing to 0.9. So 0.9 is not there, but you have two numbers that are pretty close. What are the two numbers that are close? These two, right? So you can pick this one or this one, either one. So the closest one is actually the 89.97. But if you pick the other one, it's fine too. That one corresponds to what? 1.28. So therefore the answer is 1.28. Is that okay? If you write 1.29, it's also good. Okay, any questions on this one? No? Okay. Okay, so part D, first of all, it says what? The area between minus A to A is 0.8, right? So therefore, by symmetry, this blue area has to be how much? 0.4. And this also has to be what? 0.4. Okay? Now, what is the number you have to look for? If you look for point A, it's completely wrong. Because remember, the table only works with the yellow area, or the area to the left. Is this the yellow area? No. The yellow area will be from where? From here to here, right? Since this is 0.4, up to here is 0.4, but this is 0.5, the area to the left is actually what? 0.9, and that's the one you have to look for. So therefore, the answer, we already did 0.9. How much was 0.9? How much was 0.9? 1.28. So this is 1.28. Why did I put 1? Remember that this is always 0.5. And just like this is always 0.5 too. All right, any other questions, people? Speak up. These critical values, we're going to use this a lot in chapter 7, chapter A, 9, I don't think you use this ones in 10, but in chapter 7, 8, and 9. Okay, so here, the alpha, this is the area to the right, or what we've been calling the green area. So C of alpha, so this area here to the right, this is what we're going to call alpha. Okay. So therefore, how do you figure out the yellow area? How would you do that? 1 minus 1? Alpha, right? And then this is the one you're going to look for on the table. Okay? Look for in table. Okay? Okay? So this is how the notation is going to be. The alpha is already the value or the area on the right. So this is actually very convenient once you look at the notation. Okay. This question, part A, is the same question we did at the beginning. Well, the same question we did like the previous example, actually. So here, what is this telling you? C of alpha is somewhere here, right? So in this case, it's 0.025. So what does this mean? That the green area is how much? What is it? 0.025. So then automatically, what's the area to the left for the yellow area? 0.975. We did this problem already. What was the answer to this one? 1.96. So this is what we used to call A. Now is going to be called C of alpha. So A and C of alpha is the same thing. All right? Any questions on this? And this is going to be used a lot in chapter 7, 8, and 9. Yes?
The alpha number for that z, is it always going to be the area to the right?
Yeah, whatever it is. So if I write this 0.2, it's telling you the area to the right is 0.2. So the left is 0.8. Okay? So that's always going to be the notation. Yes? All right? Any questions on that? No? So what is the area you have to the right? So you have 0.005. So remember the green area, or the area to the right, is going to be 0.0, and this thing is not working there, 0.005. Okay? So then the yellow area is going to be what, 0.9995, right? Then you look to the table, the closest thing to that is either 2.57 or what, 2.58. So either one is fine. So I'm going to go to 2.58. Right? And that's it. So any questions on this? So this is how easy this is. All right, let's do one more on this. What about this? How much is Z of 0.06? Okay, so try that one. Okay, so here, the area to the right is how much? 0.06, right? So this area is 0.06. So therefore, the area to the left will be what, 0.94. And then you look to the table. What's the closest thing to that? 1 point what? 56. That's it, right? Any questions on this? All right. 6.2. The extra thing is this formula. So you have to use this formula to change it to standard value. And once you change to standard, you're going to use the table or the calculator. So you have to do two extra things. First, read the problem, which you didn't have a problem before. The problem is always going to tell you what is the mean and what is the standard deviation. Not only that, the question will always say too, this is normally distributed or approximately normally distributed. That's how you know you're going to use this table, because the question has to say normal somewhere, okay? And then once you figure out the mean and the standard deviation, you plug it into this formula, and once you find the value for z, this is going to be identical to what we did in 6.1, okay? And this formula is on the formula sheet too. So all you have to do is plug it in. All right? Any questions on this? No? Question. It says the amount of sugar in energy drinks is normally distributed with a mean of what? 40 and a standard deviation of 7. So mu is what? 40 and the standard deviation is 7. Okay? Here, let's say that x is the amount of sugar. Okay? So what is the question really asking? Look to the question. What does it say? What is the probability that what? X is what? Greater or less? Greater than what? 54. Okay? So the first thing you have to do is use the formula to change to standard. So we do that. Z is going to be X. How much is X? 54 minus mu, which is what? 40 divided by what? 7. Okay, so minus 40, which is what? 2. Okay? Is that okay? So then the question technically becomes now, what's the probability that z is greater than what? 2. And once you get to this point, this is exactly your section 6.1. Okay, so what do? Remember you have 0 here, 2 is somewhere here, right? So what's the part that you want? The right or the left? The right, which is what we call the green area, right? If you look to the table, what's the value from the table? It's 0.9772. You can check.
How do you know that?
I memorized all the numbers. So it's 0.9772.
Okay.
Okay? So that's from the table.
I'm saying, where did you get that number from? Oh.
Okay? So that's from the C table. We just use right now. Just look to 2.0.
Okay.
Okay? So then, how do we find the green area? 1 minus what? 1 minus 0.9772, which will give you how much? 0.0228, no?
Yes.
And that's it. Now, what about you use a calculator? What is the command for the calculator? It will be normal CDF. Which one is the lower bound? 2. What's the upper bound? 1,000. And this should give you exactly also 0.0228.
Is that what you put on the
You had to, if it goes to infinity, you're going to put 1,000. If it's minus infinity, it's minus 1,000. The question is now asking what? What's the probability that the amount is between 30 and 50? Right? That's what it's asking. Is that okay? So 50. So you have to find two standard values. One for what? 30 and one for 50. So for 30, what's the first value? It's 30 minus 40 over 7, which is 1.43, right? Or 28, that's fine. And then you do it for 50.
Negative.
This is negative, yes. And this, it will be the same value, but now it will be positive, right? Right, so far so good? So then, you want the area between minus 1.43 and 1.43. Is that okay? So this is what you want. You technically, if you use the table, you are trying to find the blue areas, right? So you look to the table. Let's do the table first. What's the area to the left or the yellow area? 9 what? 2, 2, 3 twos. Okay?
Wait, how did you get that? Oh, you just used the table.
Yeah, it's a table. Okay. Now, in blue. So what's the area in blue? The first part, the first blue or now black area. What is it? This is the thing we done like 10, 20 times now. This will be 0.4222, right? This is the same thing. So by symmetry, it should be 4222 again. If they were not the same, you had to do this twice. But in this case, they are the same. So then this will be what? 0.4222 plus what? 0.4222, right? And how much is this? What is it? 4? Is that okay? 84%. Okay. All right, now, what about you use the calculator? It will be normal CDF. Remember, second variables first, normal CDF. And then this from negative 1.43, comma 1.43. And it will give you this, has to give you this same answer again. Okay? And on the test, you can do either one. So you don't have to use the table if you don't want to.
Wait, so your lower is negative 1.43?
Yes, make sure you use a minus in parentheses, otherwise it will give you an error all the time. All right, any other questions on this? Yes?
I think it gave me 8.473.
Well, then we calculated this value wrong in here.
The 0.8444 is if you did 1.42.
Yeah.
All right, well, let's go with 1.42. All right, so then this will be 1.42. We don't want to hurt the feelings, so whoever give us 1.42.
If you had 8.44 or if you had...
Either one is fine.
Either one's fine.
If you get that far, I'll be pretty glad that you got there, so it's fine. All right, any questions on this?
So the test is the same deal as last time, that if you show your work, it's better because you can get the partial.
Yes.
Rather than trying the calculator.
Yes. You should use the calculator to check the matches, but if you just write this without any work, it's not gonna work. By the way, on the test, okay, listen up to this, people. On the test, regardless of whether you use the table or the calculator, you need to have the graph in here. You don't have, if you use the table, obviously you have to have all of this. If you use the calculator, you still have to have from here to here shaded. You don't have to have these values. But my point is, if you want to get all the credit, doesn't matter use the table or the calculator, you have to have shaded the right area, and then you use the table or the calculator. Okay? All right, just try the next problem. It's the same thing. So here, how much is mu? 270. And how much is sigma? 15, right? And remember, X is the length of the human pregnancy. Okay? So the first question is asking you what? What's the probability that X is less than what? 255, right? So you need to find the z-score. So it will be 255 minus what? 270 over what? 15. Okay? So let me move this to this side. 255. And this is what? Negative 1, right? Okay, any complaints on this? All right, so then, this is the same as finding what? To finding what? The probability that z is less than how much? Negative 1. Now, negative 1 is here. So this part, this is the green area on the other side. The table will give you 0.8413. That's from the table. Okay? So then how do you get the green area? It will be 1 minus what? 0.8413. And how much is that? 1587. And that's it. Right? Now, what about you use a calculator? It will be normal CDF. The lower bound is what? Minus 1000. The upper bound is -1. It should give you the same thing. Yes?
Use positive 1.0.
Yes. Because there is no negative values on the table, so you have to use symmetry. It's the same value. But instead of giving you the area to the left, it gives you now the area to the right. All right? Any other questions on this, people? Okay. What about part B? So part B is asking you what? The probability that 255 is less than x less than 290, right? So did anybody did the C values already? So this is the same thing as the probability of what? What is it? Anybody? -1 less than Z. All right. Anybody else? 1.33. Okay. So then remember you have to always draw a diagram. So this is what you want, which is the two areas. Okay. So if you use the table first, remember from here to here, this was 0.8413 by symmetry. Right? So then how much is the first blue area, or this one? We have done this like 25,000 times now. This should be what, 0.3413, right? Now you look to the table, what's the value for 1.33? Just look to the table, how much is that? 9 what? No, it has to be 0.99 or something. Oh, 9082? Oh, I thought you said 82. All right, so then, what is this part then? The other blue area. It will be 0.4032, right? And how do you find the answer? Just add the 2. So it's 3413 plus 4032, which is what? What is it? Don't be shy. What is it? 7495? 45, huh? 45? Is that right?
I got 7.7.95, but doing math with yours it is.
Okay, so 45. All right, any complaints on this? Yes?
If I was to use a calculator, I put 1.3333, so it's obviously going to be very like little bit.
Yeah, that will change the answer. So
0.7501, would that be acceptable?
yeah, that's fine. It's okay. But if you use only 1.33, it will it's slightly different than 1.333 with a calculator. All right? Okay? Okay, now finally, in order to get into Kali Academy, you need to take a test. And on the test, you have to be in the top 6% to be accepted. It says that it's normal, so that means you have to use a normal table. The average on the test, when people take the test, is what? 700 points. And the standard deviation is 30 points. Okay? So the question is, what is the minimum score required to get into the academy? And remember, the minimum score, you have to be what on the top 6%. The formula is this, x minus mu over sigma. And if you look closely, the question is technically asking you for what? What's the variable you have to find? X. So this is the score that you need, right? And here, you already have two values. What are the two values you have? Mu, which is what? 700. And sigma, which is what? 30. Without knowing which value, z, you're never going to be able to find this problem. So therefore, this is the solution to this problem, sorry. So to find z, you had to do the inverse, or you had to go backwards. And that's what you had to do that on the side. So this is like doing two problems. So therefore, the question does tells you what? You have to be on the top what? 6%. So therefore, the question is this. So the top 6% in the normal version means this. There is some value of z, which before we used to call a, or c alpha, is the same thing, where this should be what? 0.06, because it's the top 6%, right? So then, remember, this is what the area to where? To the right, and this only works with the area to the left. We did this question already. Just check your notes, and if this was 0.06, what's the area to the left? 0.94, right? And remember, this is the value you have to look for in the table, right? And we did this already. What was the answer to this one? It was 1.56 or 1.55. I think it was 1.56. So we did this in the previous section. So then, once you find that, then it's very easy to solve the problem. Why? Because this one, now you know is how much? 1.56. Here, unfortunately, you have to use a little algebra. So how do you solve for x? You cross multiply. So you do a bit of algebra. This is what you get. X is going to be 1.56 times what? 30 plus 700. And how much is that? All right, so multiply 1.56 times 30 and then add it to 300. How much is that? It's 740 something.
6.8.
The what?
746.
746.8. So let's say 747, like the airplane. Okay? So therefore, what's the minimum score you need to get into the academy? You need to get 747 points. Which, okay, one of the things that people don't check when you have to solve this question, what is the average score? 700. Sometimes people go through the whole process and they end up with 620. So what's wrong with that? It's lower. So if you are going to be in the top 6%, it has to be higher than the average. Okay, so just keep that in mind. So then the answer is 747, and that's it. Any questions on this, people? Yes, here it is. All right, so if there is no more questions, that's it.